In this video, we're going to study some of the differentiation rules that I'm sure you already know from high school. But this time, we're going to state them formally and we'll also give the proof of some of them. So the first one is, how can we compute the derivative of the sum of two functions or scalar multiples of functions? Well, if I have that alpha is a real number and f and g are both differentiable functions at x, then f plus g and alpha times f are both differentiable at x, and also we know that the derivative of the sum is the sum of the derivative and that the derivative of a scalar multiple is a scalar multiple of the derivative. These are rules that I'm pretty sure you have already used. So we're going to prove one, and I want to leave the proof of two as an exercise. So using the definition of derivative, what we have is, well, f plus g prime is the limit as h approaches 0 of f plus g of x plus h minus f plus g of x over h. And now we need to use just the definition of this sum function, which is just that f plus g of x is f of x plus g of x. So what we have here is the limit as h approaches 0 of f of x plus h plus g of x plus h minus f of x minus g of x. So all we need to do now is to rearrange things to see if we can find the derivative of f and the derivative of g. So, well, we're going to put f together with f and g's together with g's. So we have f of x plus h minus f of x plus g of x plus h minus g of x over h. But now we can separate a fraction, and here we're just going to use the limit laws, and we end up with indeed the limit as h approaches 0 of f of x plus h minus f of x over h plus the limit as h approaches 0 of g of x plus h minus g of x over h. But this is just f prime of x plus g prime of x. And that completes the proof of number one. And as I said, number two I would leave to you as an exercise. So now let's take a look at the product rule. The product rule is a bit more complicated than the sum rule, but it's not too hard. So we have two functions f and g that I know are differentiable at point x. Then the derivative of the product is given by first function times the derivative of the second plus the second times the derivative of the first. So how can we write down the proof? Well, we first have to form these different quotients. So we have f times g of x plus h minus f times g of x over h is, well, f times g of x is just f of x times g of x. So that's what we're going to write down here. This is f of x plus h times g of x plus h minus f of x times g of x over h. And here you see we have that if we had g of x in both sides, like we would be able to factor it out and then get f of x plus h minus f of x. Or if I had, again, like only like f of x in both terms, then I would be able to factor out, but that's a problem. We cannot do that. So what we're doing here, as you see in gray, I'm subtracting and adding the same thing, so I'm not changing anything. But I'm doing it in such a way that will help me a lot. Because here, what I have is that now I have f of x plus h times g x plus h minus, you see I have f of x plus h times g of x. So now I can take common factor f of x plus h to end up with that g x plus h minus gx. And the same thing with the other bit. I can now take common factor g of x, and that would multiply f of x plus h minus f of x. So then things will begin to look like what I really want to have. So here it is after I did all the factorizations that I told you, taking factors out, putting things together, and it just looks like this. When we take the limit here, we'll see that we have the derivative of g and the derivative of f are there very clearly. G of x is very clear there, and then we have f of x plus h. And here we have to be a bit careful. We know that f is differentiable, so that will mean that f is also continuous. So when we take the limit as h approaches 0 of f of x plus h. We're good. We know that this is going to be f of x. So that's how we can do this. Okay, so we know then that the limit as h approaches 0 of f of x plus h is f of x. That would give us that first f of x that we see. Then the next thing we see when we take the limit as h approaches 0 is g prime of x. Then we have g of x, and then we have that when we take the limit as h approaches 0 of this other term, we end up with indeed f prime of x. So we have all the bits that we need are already there for us. We see also that the limits of all these terms exist, so we can use the limit laws here. So let's put all the pieces together. As I said, we know that the limit as h approaches 0 of g of x plus h minus g of x over h is g prime of x. We know that the limit as h approaches 0 of f of x plus h minus f of x over h is f prime of c. So using the limit laws, we will end up with that f times g prime of x is the limit as h approaches 0 of f of x plus h times the limit as h approaches 0 of g of x plus h minus g of x over h plus the limit as h approaches 0 of g of x times the limit as h approaches 0 of f of x plus h minus f of x all over h. But this is based on all the things that we've said so far, f of x times g prime of x plus g of x times g prime of x. Now we have another theorem, is the reciprocal rule, that if I know that my function g is differentiable and is not 0, then 1 over g is differentiable and the derivative of 1 over g is negative g prime of x over gx squared. And then we have the quotient rule that tells me that if I have f and g are differentiable functions, I know that g is not 0, then I can define the quotient f over g, so f divided by g is also going to be differentiable at x, and the derivative is given by this, is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator square. So I'll give the proof of these two for you as an exercise, and for the quotient rule you can do it in two ways. You can use the product rule and the reciprocal rules, or you can just prove the quotient rule again directly from the definition. In my opinion, it's a worthwhile exercise to do both. First, prove using the definition to prove the reciprocal rule, and then for the quotient rule, do the two different proofs to see how they differ and see what you can learn from them.